Good evening to you all, and to our colleagues online. Good evening to you all. I hope you had a great time at work today, and this is post-work. So on behalf of the Council of the institution, we welcome you all to this panel discussion, which is on AI tools and applications in civil engineering. We would be interested in knowing its relevance for Ghana, and we have a team of experts here who would delve into this topic. This particular workshop or discussion is being powered by the Civil Technical Division of the institution. And so we'll take a brief, rise briefly as we take the opening prayer. Heavenly Father, we thank you for this evening. We are grateful to you for the gift of life you've given us. We thank you for this session. And we pray that you grant us the needed wisdom to be able to understand what the experts will be teaching us. We pray that as we understand them, you also help us in applying the various activities that are related to the practice of engineering so that we shall help contribute to the quality of lives of all of us. We thank you in Jesus' name. Amen. So thank you once again for making time to join us. And our colleagues online, thank you for also making time to join us. At this point in time, I would hand over the microphone to the chairman of the Civil Technical Division to give us a few words. Then we will turn on our attention to our experts to delve into the subject matter.
Thank you, Engineer Samuel. Good evening to everybody here, and good evening to all of you. As you all know, it is one of the this is one of that we normally carry out our own professional development. This particular session, for some of us, in fact, for most of us, this is very, very green field, it's sort of alien territory, but the future is here and we have to engage it. So today's discussion about artificial intelligence will be led by a team of rather young but experienced professionals in the field of AI applications. It's actually a 4-member team. 3 of them are seated here with me at the table. There's a 4th member who is located somewhere in the United States of America, and she will be joining us. She is the female component. Those of you who have a habit of coming after us on this gender thing, I want you to know we have a member who is a lady, and she's actually sitting in America, but she will be fully present with us. Like I said, this is greenfield. Even the people in it, I don't know them very well. So I will hand over to our moderator. As for him, I know him. Engineer Aaron Duyabuating. He's the bearded man in the middle. And he will unveil the rest of the panelists for us. But what I can say is that we have a representative from academia, and then we have 3 representatives from industry, specifically the civil engineering industry. I must make a confession. The first time I really started to get interested in this AI thing was when a professor from the University of Ghana came to this very room and introduced us to AI. And today I'm happy to see that his representative is also here to make sure that we engineers don't just stray. The university is keeping an eye on us. So, Engineer Aaron, I will give you the mic and you will do what is needful so that the audience knows who we are interacting with, and why we have assembled here. We hope that by the end of the day, they will all appreciate the time that they spent here with us. Thank you.
Hello and good evening to everyone. As Chairman said, my name is Aaron Boatingdua, a professional member of the institution. And today we are here to discuss AI tools and applications in civil engineering specifically. So what I'll do is I'll introduce everyone that is on the panel today and what exactly we are going to do and what we are hoping to achieve at the end of the day. So on my extreme left is Dr. Prince Boache Setrahene. And he is a lecturer and a researcher and also a mentor in AI and digital innovation strategist with the University of Ghana, Legon. And his focus today would be to inform us about the role of AI in shaping engineering strategy and also innovation ecosystems and the future industry trends as well. On my right is my brother and a very special someone. He's Mr. Kwabna Atobra, and he's a CEO of Bloom Core Labs in Finland. So our brother is here from Finland today to also help with the discussion. And what our brother would mostly focus on is like AI tools in structural modeling, simulation, and also performance analysis. And myself, my name is Aaron Boatingdua, like I rightly mentioned, and I'm also a civil engineer and AI strategist as well. And I also work in Sweden and also here in Accra, Ghana. And my focus would mostly be in project management and automating like project management tasks and all those things, and then the tools that can be used for that. And then our beautiful sister who is online, I'm sure the cameras would show you guys who she is Ya Manua Osafo. I've also grown up with her for a very long time, and we've been working together on many things. And she's a transportation engineer with a consults engineer in Colorado in America. And what she would be talking to us about is AI application with regards to transport. So with traffic systems, simulation, and also performance analysis stuff. There would be a live demonstration as well of some tools that myself and Kwabna have also built to also show what AI is actually helping us achieve as engineers and how to be able to, do most of the tasks that we are hoping to do with ease, efficiency, and also with some sort of apps. So at the end of the day, everybody's going to touch on something that's quite important. And then we are going to have a general discussion about it because it's such an interesting phenomenon that has come into our space. And then the earlier we all catch on, I think the better it would be for all of us. Obviously, at the end, we would also open up for everybody to also ask questions. And hopefully most of the questions would go to my other colleagues and they are online. And then I'll be here to help moderate so that we'll direct all the questions to them. So yes, we should be able to have fun with this and then we can begin now. So from this very moment, I would give the chance to Doc to take us right into his lecture, which would be for a while. And then I would also come speak for a while and then Kwabna would continue. Emmanuel will take up from that and then we'll start our discussions from there. Thank you very much.
Very good evening to us all. Please, I'm a church person, so when we say good evening, you don't respond. We feel like there's no one in the room. So I know our audience online can hear us. So praise the Lord first, and then a very good evening to us. Okay, so I'm told that this is a post after work meeting. So I know some of you are tired, but like Aaron said, it's a very interesting conversation. So let me just quickly share my screen and then we'll jump right into it without wasting too much time. Okay, so hopefully our online community are able to see what our home community is seeing. Okay, so this evening, very simply and straight to the point, so we can have more time for the conversation. We just want to reflect on AI strategy and innovation. And we're looking particularly at the role for my conversation of AI in shaping engineering strategy, innovation ecosystems, and then the future of what AI is doing within the engineering discipline. We want to approach this as practical as possible, so we'll speak little so we can have more time for the demonstrations and then we can have an extended conversation. So we'll first of all attempt to break this down a bit so that this long topic that has been given is not as long as it looks like. So very briefly, looking at three things here, talking about engineering strategy, we're looking at innovation ecosystems, and then we are looking at the future industry trends. So in very simple ways, when we talk about engineering strategy, since we are engineers, I think it's easy for us to realize that we are very focused on what the kind of engineering decisions that we make. We are very interested in what we prioritize, what we invest our efforts in, how we manage the tasks that we undertake as far as our discipline is concerned, and then how do we deliver value in the end. So just to quickly sum up, when we're talking about engineering strategy, we'll jump a bit into it as we move on the slides, but this is the core focus of it. When we talk about innovative systems, it's the wider sect. We're looking at all the actors that come to play when we are going about delivering what we do. So we can talk about firms, agencies, the experts, if you want it, government, researchers, and all who come into the fold. So when we talk about an innovative ecosystem, we're just looking at every single player or actor who comes together to help us to be able to deliver whenever we are on any project or any form of consultations. Then definitely we talk about future industry trends. Just simply looking at now that there's this talk of AI and it's affecting what we do in our space, where are we heading as engineers? So it would be useful to know what all of this means to us, whether we will find ourselves in the fear of what many say that you will lose your jobs or not, and so on and so forth. But we'll have more conversation to that because apparently even truck drivers are afraid they'll lose their job because of AI. So we'll see how that goes. Okay, so let's delve right into it. So I'm mentioning engineering strategy, right? We are looking at, like I mentioned, how do we decide on what to focus on, where to invest our effort, what risks to pay attention to, and how to get the best value from limited resources, because apparently we appear to always be limited with resources. I'm yet to hear of a project that's started and every resource was fully available. There's always the talk of we have limited resources. It's either time or money or one thing or the other. And anytime we talk about strategic engineering strategy, our focus is how do the blue suggest that AI is not the one giving birth to engineering strategy. So let's have that clear. AI is not the father of engineering strategy. It has always existed. The question is, what is it coming to do? How is AI, the advent of AI, shaping that space? Very simple. AI is coming here to help in a number of things. I'll just touch on a few. It's going to help us to improve the quality and the speed for which we use in making certain decisions. Number one, the time that it will take for a number of things to be put together, number of documents to be scanned, for us to vet, to know what the gaps are within a certain space when we are doing landscaping on a project before we jump into whatever resources, right from the planning phase. AI can help us to catch up on that time in seconds, if you want, or in minutes. Or let me put it this way, the right use of AI will give us very relevant insights into these documents that help us to be able to even start in our planning phase. And since strategy is going to be the onset of the project that we usually find ourselves with, it makes sense to have done good deep dive into the kind of documents that we are reviewing to be able to make meaningful decisions, even as to how to project the timelines we'll use for a project, resources limited or not. How do we intelligently put all these together and quickly at that, because time is always of the essence. What AI will do in shaping that aspect of the strategy is to help us to get this done faster. It helps us to be able to review information. So you see, we're not just scanning them, because a scanner can do that. But when you are using an AI tool to be able to do the scanning, it's not just scanning, it's helping you to pick on insights, intelligence, useful insights that you probably may not have come to even in summary. Because if I give you a 20, well, 20 is too small. An inception report usually could go between 40 to 100 something pages just to describe what the project's about. If you need to go through 2 or 3 inception reports just to summarize what you think is relevant and where to start, I don't know which team and how many people you will need for that kind of job. But you realize then that we are going to use a lot of time just to clear that phase of a project planning. But an AI can do this for you in 30 minutes. Supposing you have so many files, the truth is that it could actually do this in 10 minutes, and so on and so forth. We've reviewed documents of huge sizes and pages in seconds. Talk of ChatGPT, Copilot, Gemini, they can all review these documents for you and give you insight that your mind will not have been able to pick up on. We are not doubting human intelligence, but the truth is that when there's intelligence higher than what you can as a human to look at in certain things, you need to come to the fold and take advantage of it. I almost said hallelujah because we began with the praise the Lord. Okay, so we move on. When it comes to a typical example, since we are in the discipline, road maintenance or drainage interventions, where you are looking to be able to ask a question like, what should we deal with first? The issue of optimization. Who should come first before the other, and in what order? If we are going to rely on reports that already exist, so historical information, defect patterns that might have been recorded over time, looking at certain conditional data that you have, AI can actually help us to be able to provide support with all of this in one fold very quickly in a very beautiful way that will beat your mind. So you realize that strategy seems to be enhanced by shortening the time it takes us to be able to cross that phase of any project that we jump into. And I think that it's always relevant to talk about strategy, because if you don't have a plan for something you're doing, then you seem to be lost yourself. Okay, so we'll move on. Okay, let's move on. Okay, now we speak about ecosystems. I'm pretty sure these actors are familiar with us, right? So this is a generic ecosystem. I'm sure it is short of a number of things, but in this basic form, you realize that we are looking at a wider environment that is helping to make innovation possible, right? So we've had all our plans strategically drafted for us. We have the AI tools, the ChatGPT, the Geminis to run through all of this for us. And then they've given us a very wonderful report, inception report. They've dotted the I's, crossed the T's for us. What next? Many a time, you realize that, as mentioned in the first slide, these actually exist already. AI is not the one that is bringing to us innovation ecosystem, because consultants, contractors, regulators, researchers, tech providers existed before AI, right? So the question here is that, what is AI going to do for us in this space? Now, there's an advantage that AI provides. AI becomes very important here because it helps these moving parts, as you can see, to work together better. Let me use a typical analogy. When a policeman stops you on the road and he asks for your license, without producing it, he should be able to tell your vehicle registration, license, and all that, just because he's also connected to the DVLA data. If there's an accident on the spot, they should be able to check your health record because NI data exists. We're talking about an ecosystem. Ecosystem suggests that we are not just existent in the silos, but we are actually connected. If there's no, so most people in tech brag with this Apple ecosystem. You hear about it, Apple ecosystem. You have your phone, your watch, your PC, they talk together. If they don't talk together, they exist. But an ecosystem suggests that they relate, they don't just exist. And one of the places AI thrives most is when there's connectivity amongst the moving parts. So you will realize that we have a lot of moving parts in our countries. Look at the projects you have worked on. There are a lot of moving parts. They always have stakeholder meetings. We come and sit down. They don't have a beautiful conversation and agree on things that we promise to do. And when we break out from that meeting and you ask what's happening, oh, we requested for this information, it hasn't arrived. We shouldn't get to that point if AI is in the play, because then it means that we're using platforms that are AI enabled, that is already speaking to our systems in the silos together. So if I need information for summary on data collected by something that's in your division, I already have access to it from the platform I'm sitting on. Please, are you with me? Okay. And that is going to help to make innovation easier to scale, because anytime we are thinking about something that we can build on top of this existing collaboration, it's easier to begin to, for want of a better word, dream. So we can become innovative knowing that our bottlenecks of silos and information they provide has been cleared, because we've agreed, and we are not just agreeing because I have to pick my phone and call you. Our systems are talking to each other. Okay, so that is for the ecosystem. What advantage does it bring to us? AI thrives on connected flows, which I just mentioned. Once the flows are connected, data is retrieved from them beautifully. Integrated workflows, most definitely, because we have platforms, data platforms that we'll use to be able to go about accessing whatever we need with whichever division and whatever platform that there is. Then we realize that the whole system can now become a bit more intelligent and provide support. Because trust me, when there's no information given, there's no intelligence. I must say here before I move on to the next slide that as much as I'm saying that AI works best with ecosystems, so the systems must be connected. Remember, however, that garbage in, garbage out. So if our systems are connected, yes, but the information I have is garbage, we are going nowhere. The intelligence you are receiving is garbage intelligence, which brings about an important thing I will make mention of when we go to the future, talking about quality data. Because once we decide to embrace this technology or this intelligence, it means then that our ways must change. How we document things must change. When we go to the field to do field assessments and inspections, the data we are collecting must be true reflection of what is there, because we are about to make informed decision on the data we want to collect. As soon as we start feeding the wrong data, we are killing ourselves. And it will not be because of the AI. It will be because we have not provided the necessary foundation for the AI to be able to harness to give us meaningful insights that engineers now will make judgment on. Okay. So that's for that. The question is, AI is helping us to plan strategically. AI is helping us to give us insights into an ecosystem of all moving parts, of all actors that come to play on projects that we are doing. So where are we going? Very, very simply, it looks, therefore, that we are not going to be doing engineering that is just sitting static in silos. The future of civil engineering is going to be more data-driven now. The reason why I said garbage in, garbage out. If you hear some of our people online talking about the fact that the data was not collected well, so you have to go and re-register, and so on and so forth, it gives you a hint that at the data collection point, if something goes wrong, that's the end. You can invest millions. It won't be about, there's no amount of money that will correct wrong data. So the fight about having to recollect data and so on and so forth. So we are going to move into a future which is data-driven. We are going to have a future which is going to allow us to be more predictive. It means that we'll start catching and predicting potential maintenance ahead of time. We won't wait for a bridge to be cracked to receive reports that we need to act fast, because data is being collected with sensors and all the IoTs you can think about periodically before we build the bridge. As the bridge is completed, as it's being used by all the relevant agencies, and we have a connected platform where we can all access to see how the data collected looks like. So we can begin to predict and say, it looks like in the next 2 months, we have to do maintenance on the bridge. We will not wait for a crack because we see the support. We're able to have intelligence systems and devices, if you want, sensors that are monitoring the health, if you want, for example, of a bridge. So after 200 cars have passed on it with total weight of about 1,000 kilograms every 2 hours, we know that there's something wrong with those parts. We would have to move quickly and go and change it and block the bridge and say maintenance. We don't need to have the bridge broken. So it means that civil engineering is going to become more proactive. We are not going to be waiting for the let's go and fix it because it's fault. The other thing is that we are going to have digital coordination. It means that all the systems that we are using, we're not saying scrap the systems we are using, but it means that we are going to have to find a way to become digitally connected, which is very easy. With all API calls on different applications now, there's a lot of technology and a lot of technicians who can allow you to share information across platforms. We don't need to scrap the one you're using so that somebody will feel politically instigated to hold on to the platform he introduced into the company. We've crossed that bridge. Use that political solution you brought. It works fine. Let's allow technology to make us share information. So we are going to have to move towards trusting digital systems, which is a problem because there's a phobia of putting what we do within the digital space. But what AI is doing for us now in the world, not just Ghana, suggests that we are moving towards a digitally coordinated era. And the quicker we catch on, like my new friend, my name is Kabna, says, you better catch on and stop swimming against the tide because you put more energy to swim against the tide than if you swim with it and learn the best practices. Then lastly, civil engineering is going to become intelligence assisted. It means that on certain phases of whatever you are doing, you're going to have to accept the intelligence that the AI is providing to you so you can, based on that, make judgments as a professional, as compared to fighting it. Like someone will chew meat and be happy until say, oh, that meat is goat meat, and he says, I don't chew goat meat. We need to realize that we'll have to be doing what we have to do. And then AI is going to be helping us. So we don't have to be fighting against me. I don't use AI. If you don't use AI, then let me bust your bubble before I move on to my last slide, I think. If you've ever typed anything in Google, right? You ever search for something in Google, you have used AI. The results that came, you have used AI. Have you ever used Google Maps? You've used AI. So what are you fighting? The AI has been sitting with you all this while. So you have been using the thing that you say just because it's not called ChatGPT. So for you, it's not AI, please. We've moved past that era. So let's embrace this future, this data-driven future, this predictive future, where we catch things before they happen and then we are known to be more proactive than reactive. Let's embrace having to be able to share data. There are so many ways to protect data when we are sharing on projects, so we don't have to worry too much about that. The technology exists, and by we Ghanaians, don't even worry about foreign solutions, where 2 units can share data and your privacy is maintained just because you are sharing the relevant data. We need to embrace that future. We need to embrace the future that AI is with us and it's come to stay. It will not go. What does that mean for us as a country? We are going to now be looking at having better infrastructure. We can start imagining building certain structures that we have only seen on TV because we are ready to be able to move towards a future that can make us dream and build things that we can build with the right information because we have assistance that shortens certain things that will take years to have done. Then we'll be able to build on having smart asset maintenance management systems and be able to have cross-sector collaborations. So as a country, yes, this future exists for us, but it's only if we are going to take opportunity of it and deliberately build ourselves for it. In closing, let me say this. The real relevance of AI in civil engineering is not that it has suddenly brought strategy. Like I said, it already exists. It has not suddenly also brought innovation, or it has not changed the field necessarily. Those things have already existed. What AI is doing is rather reshaping how decisions are made. So it's helping us to enhance delivery timelines, processes, reports, to allow us to be able to move beyond that and take steps after those decisions. And how the future of the industry is unfolding. AI is giving us a hint of how things are turning. So if you don't catch on, you'll be left behind. Then now you will fear your job. You fear losing your job, because the one who will lose the job is not the one who is not, is the one who is afraid to be able to learn to use the tool as an expert to enhance their job. The one who will lose their job is the one who decided not to learn how to use a tool to enhance their job. So if you are a doctor, this is my thank you slide. If you're a doctor, or if you are two doctors or two engineers, and you are supposed to be operating on a bridge, and now they go like, this type of bridge, we only use XYZ software, and you complained and didn't learn how to use XYZ, you've lost your job, because your other friend who learned it is the one who's giving the contract. And now he will go there and not use the theory you use, he will use XYZ software to execute the project. It will not fail, it will work. He will receive the applause and the cash, and you would have lost out. Thank you very much.
And guys, what do we say to Doc? Thank you, Doc. I would quickly also share my screen, and then we'll continue from there. Yes, so for me, we'll be looking at civil engineering tools that are used in a lot of administrative stuff. And I have specialized in solutions that make civil engineering works also very, very easy. Sometimes when you have conversations with colleague engineers, one of the things that stresses them most, and I am one of the people, but I'm trying to blame people now, is the fact that as a civil engineer, I will spend a lot of a lot of hours on the sites, and then have to come back home and have to write reports, check if everything that I have done is actually right or has been put in the right place and all that. And I sat down and I realized that there has to be a solution to this. Maybe people might not admit, but me as an engineer, I can stand here and boldly say that most of us hate report writing and administrative stuff. So as an AI enthusiast, what that actually pushed me to do is to actually come up with a tool or like a solution that would be able to put everything in one space, and then we can be able to, together share files easily, coordinate with so many things, do budgetary allocations and all those things, even as civil engineers. So we'll look into the slide and see how that goes. So then the confusion is, what is the challenge? What are we discussing? Engineers barely spend about 30 to 50% of our time on administrative tasks, like I said before. And there's heavy reliance on manual reporting, like you go into certain engineering offices and there's a lot of paperwork, writing, someone has to sign and give it to the next person and all those things. And then emails have become like the way of communication between us. Sometimes you need to get an approval for something, but you have to send someone an email and then wait for the person to respond and all that. That is the challenge. There's also fragmented workflows because one of your colleagues knows that we are supposed to do this. You, on the other hand, you're on the site and then you feel like this is what we have to do. And then there's, like no proper way to actually execute a job. And then lastly, there's limited digital systems in many of our firms in Ghana. So this is the big challenge that we have. And where does AI fits in all of this? So the first thing AI does is that it enables automation of repetitive tasks. One of the most repetitive tasks, like I rightly said, is report writing. Regardless of whatever you do, you will write reports as a civil engineer. What even irritates most of my colleagues is the fact that as a structural engineer, you would go about your calculations and everything, and then now have to sit down and do a lot of typing. I feel like people enjoy designing, analyzing, and then you have to sit down and now write with a lot of English, and engineers don't like speaking English, basically. We want to speak in our lingos and all those things, just to confuse people around us and make them know that, yeah, we know what we're talking about. So AI enables us to improve coordination across our teams, and then there's faster data processing and insights as well. And the common capabilities is that there's a natural language processing, workflow automation, and then decision support systems. That's what AI engineers. How AI generally works. So basically, we know you have to just input something. When we take the basic ChatGPT, I'm just trying to go like on a very basic level. Everybody uses ChatGPT at this point, or like Doc said, everybody uses Google. So what AI basically does is that you go to Google and the first thing you do is to just input something. Then the next thing is that in the back end of things, there are patterns basically. So what the input does is that it recognizes the patterns of what you have actually input. So if you input a prompt of, what is the best wachi that's, is being eating in the space of Spintex Road or something, there's a pattern of information that has been given that actually gives the information of the best meals, or as an engineer, the best places or competitive places to buy your cement or your iron rods. So what this prompt does is that it locates these patterns, and based on the patterns, it gives predictions. So it picks a prediction, links it to the pattern, and then it gives us the results that we want, basically. Now we go a little bit further. Like Prof said, the most popular ones that we usually use, ChatGPT, Google, those ones are the standalone AIs that we usually have. So standalone AIs, there are many of them. And what these ones do is that they are separate AI products that you can just open and use directly, basically. So all you have to do is just go to the AI tool and then ask it to help you. So you go to Google and tell Google, do this, do that, do this for me. And it's also used best for brainstorming, explaining, summarizing, drafting, and it's also fast for problem solving. The tools that we as AI enthusiasts actually come up with are the ones called the AI integrations, or the custom AI tools. So what these tools usually do is that AI integration basically means that, so let me just go back. Examples of the standalone AI tools are ChatGPT, basically what we are all using, Claude, Perplexity, and all these ones. And I'm sure at least we've all used one or most of these, if not all of them. Then we come to the custom AI integrations that I'm talking about, that most of us have built other tools that help us, get some works done and all that. And those are the custom ones that are made. And the integration just basically means that the AI is built inside of another software tool. So for example, if we take Microsoft Word, right? It's a custom integrated, maybe AI tool, but then it has, for example, ChatGPT built in there as a standalone for it to help the Microsoft Word, work faster. So there are standalone AI tools, and then there are the custom ones as well. I'll quickly jump to how the integrated or AI integrations basically work, and then we can look at that. So how do they work? The user works inside an existing app. So you are literally working inside Microsoft Word, but then you have access to other standalone tools like ChatGPT, or you're probably working in Excel, but then you have access to ChatGPT. So you don't have to necessarily close Excel and then go to ChatGPT to actually ask a question. That's what these custom AI tools work. That's how they work. Now let's look at like practical applications of these things, the custom AI integrations. A practical application for me as a civil engineer is in the space of, for example, project management, where we can use it to automate reporting, task tracking. We can also use it for transportation, and I'm sure Emmanuel would speak a lot about it, for traffic predictions and route optimization. And also for structural engineers, we can use it for design optimization and simulation reports. So where the tool I am talking about now comes in is engineering workflow for efficiency. So for me, I hated it just going back home after a long day and then having to sit behind my PC just to type a long report to send it to my boss and say, oh, today this is what happened. Today this is what I did. This is what I did. Da, da, da. And then wait for some sort of confirmation to be able to do the next thing. So then I also come up with this tool called Boojwork. And what I will be doing from this point is to just tell you exactly what this tool does for a civil engineer, or basically any engineer at all, and how that also helps improve efficiency and then our work rates one way or the other. So what this tool does is that it converts literally rough notes into structured reports. It also does a lot of automations, and it's able to bring out site reports for you. It's able to come up with minutes for you. It documents all your workflows and all that, and it tracks task deadlines, it gives deadlines, and it also shows you your responsibilities at the end of the day. Another major thing it does is that it centralizes project communication. So one thing I know is if I take a colleague's laptop, you see him have about 12 different folders. One is budgets, one is reports. The next thing is, I don't know, like materials, something. So you have different folders on a desktop just talking about one project. What this tool does is that it centralizes everything in one space, and all you just have to do is just probably just go in, talk to it. That's this is what we did, this is what we did, and then it puts everything together. And then if it's about producing a report, it produces it for you. I mean, who can use this tool? This tool is built for engineers, project managers, construction teams, as well as clients. So what this tool does is that, for example, if I have Doc as my client, and I have a project that I'm working on for Doc, when Doc also has the option to have a client view of this. So whatever I put in the project, as an engineer, I do all the reports, all the complaints, the materials I've used, Doc as a client can also sit back, log in, and look at literally everything that is also happening at the back end of things. So you don't necessarily also have to consistently call Doc and say, well, tomorrow I'm going to send you the reports for this. I'm going to do this for you. Basically, whatever has happened on site, whatever decision has been made, all Doc has to do is just sit at the back end of things and also see the progress of things, how much has been spent, who is supposed to give this order for the next thing to do, who is supposed to make an approval. You can even send approvals through this to Doc directly to approve, so that maybe a next section of a project can actually also go through as well. So I'll just do a little practical demonstration of it for you to see. So on the dashboard of this, you can see on this side, I don't know if you can see clearly, but then there's home, projects, team chats, and all those things over there. So for example, if you click on the home, this is literally what you see. So every project that you have going on, active projects, total budgets, all those things, you have all the reports. That's, for example, if it's a firm that is using it, you have everything on there. You can literally see it. So yes, we get here. So for example, you click on the projects, you look through all the projects that you have, and then you are able to see all the deadlines to the project and everything. And then, I mean, you just cycle through it. Let's just say we select the second project, which is the Second D Fish and Harbor project. So we click on that. We have a project overview over there. On this, we can see every report that has been generated on this project, basically. So we have all the reports here. We have the recent expenses that we've had. If there are any issues that were reported, we also have it there. So you can click on the reports to see whatever report has been generated on the specific projects, basically. You can click on the budget to see how much has been spent, what it has been spent on, all those things as well, on materials, which category and everything. And then you can also click on the materials option to see if there are any issues that has come up on the project. You can also put that in there as well. Yeah. And then any document that is relevant to this particular project, you can also just put it in there as well. And then there's the AI component at the very end, where you can actually, if you're on a site, on a project, and you need assistance with anything, you can get into the AI bits. I think it will get there, and then we'll see. Immediately you click on the AI bits, you have the option to have some sort of insights or have a chat with the AI and literally ask it any question, basically. So you can just ask, oh, how can I actually maximize the work I'm supposed to do today, because today I was given maybe just 10 bags instead of 15, and I don't want to, waste the whole day. What can I do? And then I think it gives you the results to that. You have the option to have a team chat as well. So it's not about sending emails. You get onto the platform, and then you can easily have a quick chat with your partners at work and everything. There's an option to also have a workspace assistance where whatever data you require from the company and all that, because this tool has been embedded with a lot of documents and facts and all that, you can actually put it in there and say, oh, what does this contract say about this project? You can just ask it over there, and it's quick to give you the information directly, to give you an informed decision about a project that you're supposed to do or something, a decision you're supposed to actually make. So there are many things you can actually do on there. The library gives you the opportunity to actually give context to the tool. And I mean, that is how you can actually train your AI to actually be able to pick out and give out information that you actually want. So if I want it to structure my reports based on how I have been writing it in the past, from the library option, I can give a context, put in a lot of documents that I have written in the past, and feed it in there. So what I do next is, if I tell it to generate a site report for me to send to Doc, it quickly looks through all the context I have given to it, and is able to structure a report that I have, done in the past, and give it to me something that is actually present and fits what I've been doing in the past, and send it to Doc. So that option is also there as well. And then, like I said before, there's an option where you can also get approvals and everything. So, if you want to send approvals to other colleagues to be able to give you the approvals to see through other things as well, the platform is there for you to actually do that. And then there's the general analytics of things. Now we are all about the analytics. Even in football, before a team buys someone, they want to know how many dribbles, how many, goals, how many tackles, and all those things. Because a lot of us make informed decisions based on analytics. Data is important, basically. So we need to see, to be able to believe and make informed decisions about it. And most of the times, the kind of clients or people we deal with are all about the optics. They want to see how much you've spent. They want to see how much you've used with regards to materials. You don't necessarily have to do anything. Once you input, oh, we've used 10 bags, we've used 10 CDs, we've used 15 CDs, the tool itself generates all these things for you, and you're able to see everything going forward as well. How is this of value to engineers? Basically, like I said, it saves a lot of time. It reduces a lot of errors. I feel like when I started using my tool like this, I can spend a lot more time focused on my calculations and my analysis, more than having to see whether I made an error in my report, or if my report is okay for my boss, for me to send to the clients and all those things. I spend a lot more time, taking up more tasks with my calculations and all my analysis, or I try to be more daring and look through all my calculations all over again, rather than actually spending time writing reports over and over and over and over again. And why does this matter? There's increase in efficiency for small and large firms. There's better project delivery and accountability, which is very, very good in the space where we are, because there's no accountability for everything. And then there's also reduced administrative burden for everybody. And obviously we can scale solutions without heavy infrastructure. I would end my presentation by saying that, this is just not a concept, obviously. Everything that we try to discuss and or find solutions to are just not concepts. This is a working solution that is designed specifically to solve the everyday inefficiencies engineers face, especially in environments like Ghana where workflows are still very largely manual. So this is a tool that is very open to everybody to try out and see. There will be a demonstration over here where you can come and try it. And then at the end of the day, obviously, everybody can have a feel of it. So thank you very much. I'll give the microphone to Kwabena to also do the next presentation.
Hello. Thanks for joining us today. I think those were very excellent presentations from the two speakers. I'm going to describe what we do at Bloomcore. And first of all, I'll give a background, what kind of company we are and what our core focus is. So Bloomcore is an early stage startup. We are based in Finland, in Helsinki, and we are an applied AI lab. And what we do basically is that we build autonomous and collaborative AI agents for civil engineering and construction. Our stated mission is to largely build, let's say, the cognitive layer for the built world. So if you look at our built environment, things are pretty static. There isn't any intelligence layer that kind of orchestrates and connects it. And that's our ambition and our mission to sort of solve. This is our team. So I don't know, kind of looks a bit blurry from the side, but myself, Kwabena, the CEO, my background is largely in geological engineering. Currently, my bread and butter is more on computational science and engineering. So I run a lot of finite element models and numerical models. And my co-founder, Eugene, he has spent most of his life building like core software for companies like Airbus, Nokia, Ericsson. And we also have our go-to-market partner, Yako. He's spent most of the better part of a decade in commercial sales, previously worked at Google, and also Dun & Bradstreet as a country manager for Finland. So my presentation is going to be quite short because I prepared for a 10-minute presentation. But yeah, if we're going to interact with Polaris during the demo part. But Polaris is our first AI agent. It's built purposely to run structural optimization via full finite element analysis done in minutes, largely in the cloud and device agnostic, meaning you can pick your phone, access Polaris, run any numerical analysis you want to run on any building structure that you would have. And this sort of the idealized, let's say, workflow that we are largely trying to solve. So there's the structural geometry part where you can, via natural language, create a structural geometry of a building. Now, that is a tall order in the sense that buildings can take very different types of shapes. But for the basic building blocks, kind of works quite well. And the goal is to keep increasing that capability. Also, if you have an already existing building, mostly in IFC format, and I'll explain why we prefer IFC format, you can already upload it in Polaris, and Polaris can start building on top of it. Then there's load analysis. Basically, you're tracking how loads move within your building. And let's say component analysis, or let's say analyzing the deformations, stresses, deflections that are happening in the elements in your building. Compliance validation is basically you're trying to check your design against certain established building codes. So mostly in our case, we have integrated the Euro code. So the agent tracks how things are based on what the Eurocode guidelines are that you are supposed to meet. Then there's the optimization part where based on some design outputs, you want to sort of recalibrate, want to make some changes and then reanalyze again. And of course, there's a documentation and drafting part that most people don't like, but it's sort of part of the business for some reason. So I'll give a high-level system architecture of Polaris, and I'd like to start first with what Polaris is not. And I think there's a huge confusion when it comes to how AI, specifically LLMs, are used in engineering. Most people think that if you are using AI to sort of do a design, let's say design a building, it means you are giving ChatGPT, the generic ChatGPT or generic Claude, some command, hey, design me a 5-story, and then it goes and it can do it perfectly. That is not how we do it in Polaris, and usually that's not how anybody will want to do it, mainly because LLMs are generally stochastic, right? In the sense that even for the same query, you'll get slightly or even vastly different outputs. And as engineers, that's like the wrong thing to do. So what you do is that you sort of replace the LLM with an AI system that has a number of things. And what we have is the LLM reasoning context. So Aaron mentioned context is important. In our case, context includes all the best practices, right? So what are the best practices for modeling beams? What are the best practices for modeling columns or modeling, et cetera, you encode all of that in your context database that your agent is able to access when it knows that it has to analyze a beam, right? So you don't want it to go in there blind. Then we have a RAG pipeline, and RAG is basically retrieval augmented generation. And basically the way it works is that when a query comes in, we check what it's closest to semantically with what we already have. Right. So let's say I want to design, let's say a 5-story building, and there's information in my context DB about how to sort of deal with 5-story buildings. So let's say I've designed a 5-story building before, that information exists. I want to be able to pull and reference it on the fly without me going in there to dig for it. So that's what a RAG pipeline does. Then we have our toolbox, and I would expand more on what happens in the toolbox. But basically in the toolbox, we have standard engineering tools, and mostly we build on open source tools that human engineers would also use. So we can have a CAD tool in the toolbox, you can have a simulation tool in the toolbox, you can have a modification tool in the toolbox. And the agent is aware of those tools that are in the toolbox, their capabilities, what their input-output file formats have to be, and so it's able to access them and put things in the right way. Then we have evals. So evals basically are a way for us to measure that the agent is taking the right steps. So for example, we want to do a design of a house. It wouldn't make sense that the agent starts by saying, I've run some simulation or nothing. Right? So you want to be able to track the steps that the agent is taking whenever it gets a task, and be able to have a way of scoring it and getting it to do the things in the right steps so that the outputs are coherent. And then we have memory. Memory is basically, one good thing about AI is that whenever I do something, I should be able to leverage it, right? So leverage is a core thing, and we all do it as humans. When you learn something, it's in your memory, you're able to access it when you're doing a next task. And LLMs by themselves, they are usually stateless and they're usually memoryless. So Every time you start it, it's a cold start, right? But you don't want to have that. You want to have a memory that the agent is able to reference on some steps it took in the past that went well and be able to access it and use it on the next task. One thing that is missing that I should have added is guardrails. So guardrails are a way of preventing the agent from doing something catastrophically wrong, right? So it's a limit that you set on the agent. So you can say, okay, I give you a limit not to even attempt to design, let's say, 20-story buildings, for example, or X, Y, and Z, because you're just not at the point where you can trust the agent to do that, right? So there are guardrails as well. And the way we interact with the output is that instead of just producing static outputs, we want to generate the outputs and we want to be able to learn from them. So if you can see from the dotted line, beyond the generation from the AI system to the analysis and design output, there's a reflection loop or the reflection layer. And basically, it's the same thing that you do. You first do an analysis, you look at it, you think through it. Okay, this design choices that I made, they make sense, right? And how could they go wrong? And you want to give the AI the same ability to do that. So after it produces an output, it should be able to think through the output and get back to see, okay, do I need to correct something? What are the tools I need to use to correct that? And that's what the reflection loop there represents. Then you can see that we have the collaboration loop. So basically, the agent can come back to the user and say, hey, I need more context, or I need more information, or do you want to do X? And it should be able to come back to you so that you specify more things when it needs more information. So that's how Polaris is built. So when you look at the current toolbox, we have 4 main high-level tools. Some of these tools have their own sub-tools just in there, but all that is abstracted away for this presentation. But we have let's say the geometry tool, and we build it on top of an open source CAD tool. And as you see on the top, we build mostly on open source, that we don't have any vendor lock-in or file format lock-in. If you use Autodesk, the way they make money is that they force you to stick with it, and a lot of things are abstracted away from you. You cannot really query what is going on under the hood. And we try to avoid that by building on open source tools. So we have like a FreeCAD, which is an open source version of, let's say, AutoCAD. AutoCAD is more powerful, but for the purposes of the things that you do, the features in FreeCAD are sufficient for you to do that. But most engineers would not use it because you get to a company, everybody's using some cracked version of AutoCAD or some paid for version of AutoCAD, so everybody just joins the train. But we can already break that with this. So the way it actually works under the hood is that we are using code gen, so code generation. So every tool you have has a scripting language behind it. And so we generate the code that accesses the scripts behind to generate the code snippets that, when executed, will render the geometry that you would be able to see. Then we have the BIM tool. So basically it tracks like all the elements in the building, their positions, volumes, which elements are connected to it. So I see a beam, it is connected to other, some columns, some slabs, I don't know, it's tracking all that. And we do that via IFC OpenShell. Then we have modification tool. And here it's more custom built. So we call it a patch engine. And the reason why we call it a patch engine is that we take the IFC file and we are patching it based on the changes that the human wants to be done. So here too, we use like code snippets. So we have a code snippet that it's good at, let's say, making changes on beams, making changes on columns, making changes on slabs, making changes on groups of columns, making changes on groups of slabs, So when a user wants to make even granular changes, the agent knows, okay, I call it modification tool and I know what code snippet to take and execute, right? And that's what happens in the patch engine. Then we have the simulation tool, and basically you are running a full 3D solid deformation model. So you're not doing some kind of symbolic analysis. You're actually creating the geometry. You are meshing it, you are imposing boundary conditions, and you are running the numerical model on that system. And it's all happening in the cloud. You don't need to lift a finger, right? You don't need to set it up locally on your environment. And the meshing is done with Gmesh. Gmesh is a general purpose meshing tool. It's used in different domains for even CFD analysis. Then currently the simulator that we use is Calculus. Calculus is a general purpose finite element solver, and we use that. Then we have the simulation tool has other internal tools for pre-processing, post-processing, and so on and so forth. Core features available at the moment. So basically we have like an end-to-end FEA pipeline. So you can run finite element analysis end-to-end just by talking to the system, like just by texting the system. Like this is incredibly powerful, right? Up until now, for people to run numerical models, you have to, train yourself, know how to get a tool on your system, set it up, run it. But you can already do that. If you're connected to the internet, you can have that FEA pipeline done. Then automatic structural optimization. So if you have some IFC file and you want to see, okay, can I optimize it a bit further? Like, okay, can I play a bit with the geometries, with the materials a bit to see if it's still fine? You can already put it in and it can help you do that. Then tool orchestration. Let's say one thing that prevents people from switching from these, let's say, vendor-logged tools is that most people don't want to learn other tools. It's a huge barrier, right? So I know AutoCAD. I have all my stuff in AutoCAD. I prefer to just open it and do stuff. Even if there's a free version, I would rather go for the cracked version. And there's a way to avoid that by using a tool that prevents you from jumping on that learning curve, because all that learning curve is abstracted away from you when the agent is doing the heavy lifting. So there's really no excuse to stay logged into systems that you don't want, right? Or systems that are too expensive for you. Then there's the cognitive layer on top of customer data. And this links very well with Doc's presentation. He mentioned, there should be an ecosystem. And most companies have data sitting in silos, it's also on somebody's laptop somewhere. Maybe the company has done incredible work on some project before, but it's not easily accessible to everyone else in the company. Now you can easily bridge that because everything sits in Polaris. You give a query, you can instruct the agent to first check for comparable projects that have been done. You can pull all the documentation, the IFC, you can start building on top of it. So really, there's no way you want to do this other than this. Then, as I said, it's fully cloud native. You can even access it with your phone. Then this is what I call like the AI native interaction layer. We are not going to interact with our technology the way we've been doing for years. It's going to be more natural language. You're going to talk to systems. You're going to text systems, and you're going to get them done. And this already gives you the preview on how to do that. So I didn't put a demo in, I just put some snapshots, but during the demo session, you can access it. Yeah. Then last two slides. So I would say some of the core application areas that we see that immediately we can be of help to people is just rapid. One of them is rapid structural prototyping. Let's say you're having a chat with your colleague, you want to do this building, you don't need to open AutoCAD or stuff, just, okay, let's just give it to Polaris and see what it comes up with, right? And then you can see and say, okay, we don't like this design, it's crap, let's do something else. And let's try a different thing. Let's give it a different task to do. So you can rapidly prototype things. You can do automatic design and optimization. So you can already start with, doing all the fine details in your IFC file, give the file to Polaris and just let it, analyze it, try to optimize it, and then take your final file out. Then there's real-time information retrieval with no data silos. This is extremely key. It's incredible how much productivity loss is from data silos. Imagine you're on a team and there's a senior engineer, he has all the knowledge in the world, but nobody can access it. Like, it's no longer useful at that point, right? You want it available to people on demand. And once everything is in Polaris, anybody can access it. The collective intelligence of the system just goes up exponentially, and it's a win-win for everybody. Then real-time automatic structural health monitoring. And this fits extremely well with what Doc said. The build to what else we have it now, it's just, I don't want to use the word dumb, but it's not intelligent, right? There's no way for us to know, okay, what is happening really internally within our beams, our slabs, but we can change that with low-cost sensors, right? So you can easily put sensors on some critically stressed columns or beams, and very simply, instead of having a human analyze that data, Polaris can analyze that data. And you just overnight change the whole state of your building. Your building is no longer static, it's intelligent. There's a brain behind it. Something is managing it and doing it well. And that's where we want to get to. Then of course that unlocks a lot of things. You can do more predictive analysis on your building. Even forensic analysis can be done more proactively and better. But most importantly, it becomes trivial and cheap to create digital twins. And people don't understand how important digital twins are when it comes to physical assets, because you want to have real-time information about the state of your assets. Like, if you do that in manufacturing, like, there's no reason we can't do that in construction and engineering. When there's a large building, we have to be able to know at every point in time how the building elements are being stressed. And we can do that with low-cost sensors. You can put one or two sensors in some beams, but Polaris is sort of analyzing the entire building. It can check on this critical beam. This is my prediction. This is the actual thing coming from the data. It can recalibrate its assumptions about the rest of the information. So we have complete information about the building with very little capital injection. And that's the unlock that this makes possible. So finally, I'll end with, I'm always asking for things. So bear with me, I'm going to ask you for a few things. So we are looking for partnerships, one on data. Data is extremely key. So your company, you're an organization, you have data sitting on laptops. We like that. We will come in there, use our resources to make it ready for Polaris to be able to use and access for the benefit of everybody. And on regulation, one of the things that motivated me to come here today was I was just so moved by the GHIE, participating in this. And this is the body that would set the tone, the guidelines that would make sort of AI adoption in this field in Ghana possible. And we want them to bring all the regulations that they think. We will just make it accessible in Polaris. Make it trivial for engineers to access. What are the guidelines for designing, I don't know, foundations, whatever. Anybody can sit in the quiet of their room and access it on the fly. That's what we are trying to do. And projects, if you have some ongoing projects and you want to see how Polaris might do on it, we're happy to let it join. And trainings, if for some reason you want to let your people become AI ready and you need training, we can just come in and show you how to interact with Polaris, what to do, etc. So yeah, that's it from my side today, and looking forward to the rest of the discussion.
The next presentation will be given to us by Amanwa. So.
Yeah, well, I'll start with a funny incident that happened. Great presentation, by the way, at Tobra. Aaron and I are in the same class. We're in the same class from KNUST, and Never once did I call him Aaron. Never once did he call himself Aaron. He was better known by his nickname, which I want to mention here. So when he texted me about this webinar, he referred to himself as Aaron, and I was positive that someone had hacked his phone. So just a quick little reminder, if you ever contact me, beware that I have natural social data on you, and I'm always processing this in the background to see if you're real. Anyway, my hope today is that after this presentation, we'll have a shift in how we think about what's possible, especially in the United States. I have two main things I want to share with you today, and they're intertwined. The first one is this. A lot of the barriers that we once faced, are quickly disappearing with AI. So for example, I do a lot of traffic microsimulation. And not long ago, running a microsimulation model required software with expensive licenses. If you use Vissim and AIMSOM, you know what I'm talking about. These licenses usually cost thousands of dollars. But now with AI tools, AI can now help engineers build and calibrate models fast without needing deep coding backgrounds. Generative tools like Claude means that engineers can now write scripts, sets, and generate reports by describing them. So things like, what software do we need, and can we afford that software? The challenge now becomes clearly understanding the problem and using AI tools to systematically develop solutions. Now, building up on this point, with some of the constraints out of the way, we can now have the freedom to reimagine what engineering solutions for Ghana can look like. And this is where I want to spend a lot of my time. Going back to my example on microsimulation, we can create scenarios that apply to us from scratch instead of adapting Western tools to our local context. So, so the solution is very basic. And what this basic simulation can do for us is to give us more insights into the additional delays experienced due to the presence of hawkers. This is not something that you can do in Vissim because the context is very different. In my experience, the closest thing to the Ghanaian context is when the Indians make microsimulations in Vissim. That's the closest that I have seen. But here, Claude made some assumptions and created variables like traffic volume, hawker count, red light duration, the speed of hawkers. Can you see my video? I guess. Yeah. Okay, so you can, sure. And all of this is from a very simple prompt. In reality, you would have to give the AI some structure, just like Atabra mentioned earlier. Now, imagine if I sat down and gave it some more thought and applied engineering principles and calibrated it with actual data collected from the field. What would happen is we could stimulate different engineering solutions. And the icing on the cake, like I mentioned, is that you don't even need to know how to code. AI can make the process of learning how to code much quicker. The next example that I'll give is in asset management. So I'm affiliated with a Ghanaian-owned consulting company called Infinicity Labs, And they've moved on from dreaming about what these AI tools can do to actually implementing these solutions on the ground. And they do infrastructure asset management for different agencies. One of the things they do is to track the conditions of roadways faster than we would traditionally do with business. They use a lot of apps to predict use and this. And then they show their models. Conditions of the case and so they can easily be mapped and visualized. This is important because with a tool like this, we can easily prioritize projects and allocate funds. So imagine if you wanted to prioritize maintenance of roadways in Accra or Takoradi, this method will make things more efficient. And one more plug for Infinicity Labs. They do more than just advanced assets and infrastructure management systems. They also work on traffic management control systems and farm management systems. So by collecting continuous data across corridors, AI can analyze this high resolution inputs to improve outcomes for the entire network. For example, we can use low-cost cameras and place them as strategic sections of, say, strategic sections along, for example, Tech Junction to Ameko in Kumasi. And the information that we get from these low-cost cameras can help us create a solid coordinated corridor to improve traffic progression. This is a sample of what AI can do with traffic flow and optimization. So has come to stay and is changing the world as we know it. The challenge for us is how to influence how it's applied. And one last plug, I'm moving back to Ghana in January next year, and I'm excited to work with other engineers to use AI to shape the next decade of infrastructure on this continent. Oh, and that's it from me. Thank you. Well, I hope you're able to hear at least a little bit of it.
It seems we've come to the end of the individual presentations. So when we get our moderator back on the podium, then we will open the floor for open discussions. I'm sure those of us who've listened, both here and online, have a lot of questions and would need certain clarifications and stuff like that. So kindly give ourselves about 3 minutes, just stretch and then relax later. Our moderator engages on private matters. When he finishes, he will join us, then we can continue. So just take a couple of minutes, just stretch. We should have made an announcement at the beginning. We have washrooms to the left side here. So those doors will lead you to the washroom. Anybody who needs to sort himself or herself out could just step out for a couple of minutes. Thank you. So 2 minutes, just say hi to the person next to you, get to know yourselves before we start the second session, please. A small announcement, please. We want everybody to take note. Everybody who is participating in this exercise should please register. Those of us in the room physically, use a QR code which is going around to register. And those of you virtual attendees to kindly register. This particular activity will give 2 PDH hours for our CPD awards. So we want everybody participating to register their attendance so that we will know who should benefit from the PDH hours. Thank you very much.
Hello?
So whilst we're waiting, we can just quickly do a demonstration with the Boujwek tool that I mentioned before. And if anyone has any question or something they would want to try out, you can easily let me know and then we can all like do it together. Can everybody see my screen, those online? Okay, so like I said, this tool is basically good for administrative stuff, with managing projects, helping coordination and workflow, as well as like budgetary and also giving a very good graphic for analytics and everything. So when you go to the Home tab, basically it gives you like the dashboard of everything that is literally happening. So you can see the active projects. That's a firm or you as an engineer you're working on. You can see the total budgets of all the projects that you're basically doing, as well as how much you have spent. And then you can literally see all the reports that you've been able to generate with respect to every project that is going on in the firm. So now, for example, let's click on the projects. And then this gives us all the projects that is going on. Yeah, I am more. Are those online able to see my screen? They can, right? Yeah. You can see it. Okay. So yeah, so for example, these are all the ongoing projects. And let's take it as if a firm is the one using this tool. So we have about 13 projects. What this interface shows you is the projects that have been completed, those that you're still planning, how much is the sum of the whole project, how much has been spent, and all that. So let's just click on the Secondary Fish Harbor Coastal Facility project. So once you get into any project, this is the interface you're going to see. You're going to see a general overview. If there has been any reports that have been generated with this project, you're going to see it here. You're going to see the budgets, materials, issues, documents, and then the AI components as well. Another thing you can do is when you open a project, you can take daily notes. So if I'm on site and I see something happening, I can quickly take daily notes of it. I think my internet is failing, but there's a chance, there's a choice to also record like a voice note or something and let the tool transcribe it for you, and then you can save it, and then later when you get home you can work on that as a report and then just easily save it. So yeah, that's also an option there. Then you come to every report that has been generated with respect to this secondary fish project. You can see it, you can have access to it. You look at the budgets, how much has been allocated, how much has been spent, the materials, you can see how much has been used, the stocks that you have, how much, you don't have and what you have to order. If you're on site and you have any issues, you can easily input them there. You can actually label them with how severe it is, as a low impact issue or as a medium or a high, or if it's critical as well, you can actually do that. Then if there's any document that is in relation to this project and you want to actually upload it as well, you can also do that. Then there's the AI component on each project. Once you click on the AI components, it gives you a first 4 open options where you can do risk assessments on the project that you are doing. You can do the risk assessments because you have fed this tool with context about this project. So if you have talked about issues that have happened, if you have talked about problems with weather, all those things, you can quickly click on the risk assessment button and it will give you a quick analysis of what is really happening with the project. Or you can do a quick quality control based on the context or the information you have fed into this tool about this specific project. Or you can literally come here and generate a monthly reports, put a date and time here. So for example, from 1st of March till maybe 1st of April. And then you ask the tool to generate a report for you based on everything that you have put in this tool from the beginning of this project. So what it does is that it will generate this report for you based on anything and everything that you have put in there. And like I said, you give context to the tool. So what the tool does is that based on your past reports that you have already written and you have put it in there, it looks at that, it looks at the formats. If there's a headliner you want to put in there, that's what it does. And then it generates everything for you. And then you can save the reports and then send it to a client or send it to a colleague directly. You can also do daily reports or even a client summary. So you can actually, if you want to send something directly to the client, you can click on that, generate that report, and then send it as well. Or you can just literally have a chat with the AI and say, I mean, like, what's happening with this project, basically. And then it literally tells you every information that you need to know about the project. That's what the tool does for you. So you can actually do that with literally every single project on here. And I mean, anyone that has access to this tool, if it's a firm and your colleagues working, once they open this, they can also have access to every report you have generated, every information you have fed it, basically. These are the analytics. So it literally informs you about everything that is going on. So the total projects, how much has been spent, total that has been spent, and it gives you, graphs that's actually you can look at and actually make informed decisions also from. You can understand and analyze your expenses, the number of reports that you have been able to generate and send out and all that. It does all these generations for you based on what you have actually put in. It gives, when you go to the approval option as well, colleagues can send out approvals to other colleagues as well. And then once you open your interface, if you think, oh, we need maybe Emmanuel to buy 50 bags and Emmanuel is not here, but he has sent the approval, I can approve it here. Emmanuel can easily just buy it from there. You can also do that. It gives you the reminders of things and tasks that you literally have to do as well. You can add your reminders basically, and everybody that logs in can see what Kwabna is doing, what Kofi is doing at a certain time in the day as well. And there's the option for the team chat as well. So everybody in the company can literally just talk to each other and, I mean, literally just get instant responses as well. I think the internet is slow, so please bear with me. And this is the workspace AI where you can literally ask your workspace about things that are literally happening. So you can ask about your company based on the context you have given to it. So what are the core values of this company? What are we seeking to achieve in the next quarter? What are we supposed to do within this week or something? It's also going to be able to inform you with all those things. And the option for the library is where you feed this tool with the context of what you want the tool to basically know. So all the documents, the files, the information you want this tool to have, all you have to do is just put it in the library. And once it saves it, based on subsequent reports you try to generate or information that you try to give to the tool, it will be able to look at the context that you have given it and give out the reports and or information about whatever you want to do. An example I would want to give is, for example, with this highway and road constructions that we are given, if you are a contractor on like a road project and you have consistently given like maybe traffic counts to a specific road, information to this tool. If you want to block a road at a certain time of the day or something, you can literally ask the AI tool here that what is the best decision I can do with a roadblock? And based on the information that this AI tool has received from you about maybe the number of cars that passes on that road within a specific time, is able to advise you on the best roadblock options that you can actually, use to avoid causing like some sort of congestions and all that. So based on the information that you have fed it, it can give you like the best advice to actually proceed with any project or any activity that you have to do. So this is how the Bootwork basically works. I wish I could show you how the audio option works, but clearly it's not working. It keeps loading, and I don't know if it's because of the internet, but literally, this is how the Bootwork option works. So Kwabna will come to also show you how the Polaris also works, and then we can just proceed from there.
Somehow it's not responding. Yeah, there's always the demo effect when you do live demos. So I would say we can start with a very basic example where let's say a client wants you to design, let's say, I don't know, wants a 7-story building. How do I proceed? Okay, so we can give Polaris this prompt and then you can say, okay, so here it goes into the context DB and looks for what it thinks it needs to proceed with solving the problem. So it believes that it needs to have a general idea of what a building shape has to be, what dimensions, what are the layouts, what materials it should try to use. And then it also says, alternatively, would you like me to browse existing 7-story buildings, right? So maybe we can say, yeah, go ahead and browse. And then it's going to use a different sub tool. It's a fetch tool. Then it runs a semantic search algorithm that checks for which example buildings already exist, and it returns the top 3 for you to look at and see which one you want to build on. So here it's the best match was a 7-story building. We can try to look at the rendered geometry. So it's slow. You can rotate it. Yeah, you can rotate, zoom in, zoom out, look at each element in detail. Then what material assigned. So currently there's no material assigned. Then I can say, well, if I look at all these examples, it returned the next best option was a 6-story building. I don't want that. And a 5-story building and so on. So I can say, choose, it's response is a bit weird. Let me see, okay, it's there. Choose design 1 and assign materials, let's see. So it would decide, okay, then I'll choose design 1 and I'll use my modification tool. So it will use a modification tool and assign materials. So as I said, there are code snippets on how to assign materials. So assign concrete, assign steel, whatever, and then it would assign which one it thinks is appropriate. This step, depending on how many elements are in the structure, can take somewhere of around 2 minutes, and then it would proceed. Yeah, so it will tell you, it gives you a summary. So there's also one thing about traceability, and you, the engineer, nothing is a black box, right? It tells you what it's doing, what are your next options, and then you can also view it again. So it's still the 7-story, it's assigned the materials, so you can proceed. So I can say simulate. Oh, simulate. And then it will choose the simulation tool, because now it can simulate. So it will run your simulation. And this is running, as I said, in the cloud. What happens is that everything is running in parallel, right? So we are simulating several batches of beams, several batches of columns, several batches of slabs. So this would we've calibrated a system that simulations take around 5 minutes. Of course, we can increase our compute resources and bring it out to 1 minute or 2 minutes or whatever, but our current compute resources ensures that all manner of simulations run approximately around 5 minutes. Yeah, so we would wait, and then in about 5 minutes, we will be able to see what the stress and deflections are or deformations are in the building. Yeah. Can also ask questions. I don't know if you pass the time, but yeah. Okay, so I can talk about something else that probably I wouldn't demonstrate, but so here I'm using Polaris as a co-pilot. So I'm giving it like step-by-step instructions. I could also prompt it in a way that it works as a true agent where it doesn't stop for my instructions. It will just auto-accept its own recommendations, reflect on them, and continue. So that's one way to also look at it. Yeah, so it runs the simulation, it checks a summary, and it sees there are some elements that are under designed. Right, yeah, okay, cool. You can look at the building, click on individual elements, look at some summary. So you run a post-processor. You can look at some stress distributions and deformations or displacements in a material. You can rotate. So here, you probably put in a point load in some part of the building. So here you can, of course, tell it to run the loads a bit differently. And you can look at the stresses, rotate them on individual elements. You can look at some columns as well, and just basically standard things that any computational engineer would do. They have a solid body, they've run analysis on it, they're looking at the stress and displacements on that. Then, of course, it gives you a summary, and then it also gives you some key engineering observations that it thinks it saw. You can tell it, okay, apply changes, because it's trying to help you get to a certain goal, and I'll give it an extra information and use a minimum factor of safety. Of, let's say, 1.5. And then it would accept the changes that are recommended, but now it's working with new information. So you can give it whatever new information. You can also give it constraints. So you can't go beyond this type of material, assign your reinforcement ratios cannot go beyond this. So you can give it whatever. One other thing is that we have this download button for this calculus imp file. So you can download this file, and it basically stores all the simulation information. So you can take that file, put it in your own calculus environment and run it and just verify, right? So everything, it's not a black box. The intermediate outputs are available for you to see, to access, to probe, and to query. And that's the philosophy that we have behind this. I don't know how much time I have to try a different demo, but yeah. And again, please, you can go to polaris.bloomcorelabs.com on your phone, on your iPad, just with Google and Microsoft login, you can already access it for free and just play with it, give it a go. And we are always happy to know when it's failing, and then we know how to fix it. So it's still an infant. It's think of it as a very little engineer that is going to make a lot of mistakes, but we are here to, let it get better. The way I like to look at it is that this is the worst it can possibly get. So it only goes uphill from here. So just sign in and let me know how things are going. Okay. So it's working. And since it's in the cloud, you can close your laptop, leave, come back, it'll work, and then you come and see the output. So You don't have to babysit it if you don't have to. I think I'll end it here, and then see me if you want more detailed demos. Yeah.
Thank you, Kapna. So I think where we are trying to do a little bit of engagement. I think we are far behind time. So I would ask our panelists a few questions, and if anyone has questions as well to them, you can actually direct it to them, and they can also ask questions so we can all get some understanding before we go. What I'll do is that I'll send my first question out to Amanwa. Yes, so there's a general question that I would want to ask you that what are the opportunities that you think exist for AI to improve urban mobility in cities like Accra, Kumasi, Takoradi, and like other big cities here in Ghana?
Okay, thank you. Yeah, I needed to be unmuted, but thanks for the question. I truly believe that Ghana actually has a huge opportunity to leapfrog some of these traditional systems of transportation. For a very long time, we have used Western calibrated models for our transportation system, and that has worked for us, but it has been limited. And now we have the capacity and the bandwidth through AI to do a lot of research and come up with relevant parameters to improve mobility in our cities. So some examples that come to mind are that for trotros and shared taxis, AI can help us predict demand or optimize routes. And AI can also help us analyze travel patterns. Last year, my sister-in-law told me that she left home for 31st December watch night and ended up seeing the new year in traffic. So AI can help us analyze travel patterns during different seasons so that we can come up with solutions. Those are some of the examples that come to mind. I have been to Takoradi a couple of times, but what I remember is that Market Circle was very congested, not just with vehicles, but with pedestrians as well. So I think AI can help us analyze how these two road users can interact for better flow. And like I mentioned earlier, so far as you're able to collect data digitally, there's endless possibilities to what AI can help us analyze in terms of traffic operations in our cities. So that's what I'd have to say.
Thank you, Emmanuel. That's a very critical question, and I know that a lot of our structural engineers yes, a lot of structural engineers who are interested in what you have created would be very keen to know and find out. So are there reliability and safety considerations when using like an AI tool in structural engineering? I mean, you can also use Polaris as an example. What are some of the considerations that you put in as well?
Thanks. I think that's probably one of the most critical questions. And as I showed in the way our system is organized, you want it to be transparent. You don't want it to be a black box. So the intermediate steps that is taken, you want the engineer to be able to have access to it. That's the first step. And you also don't want to have, let's say, design outputs coming out of an LLM itself. Because most people are not aware, LLMs are generally, they're like statistical engines. They're just predicting what's the next probable word or there's a token that would come. And by definition, that is not how you would organize any engineering system. So anytime somebody says, okay, there's an AI tool that does analysis or engineering analysis, you want to make sure that it's not just coming out of an LLM, right? even though the LLM will be core at how it works, it should be coming out of tools that engineers already use and leverage. And that's what we try to do in Polaris. And the other thing is on, let's say, evals and guardrails. So one thing that it's not probably clear in my presentation is that we do have guardrails. So as you see now in Polaris, most of the things you do are probably basic building configurations or shapes, and it's by design. We try to do it such that what Polaris is allowed to meaningfully attempt are things that we've vetted, we've audited, and we know that it can sort of reliably, to a good degree, generate those kind of outputs. And so you want to have those kind of guardrails and evals in the system. But as you said, it's just going to get more and more used, and it's going to get more and more better in that sense.
Thank you so much. Doc, quick one. I think when you ended your presentation, one of the things you said was the fact that people have a reaction to, oh, me, I don't want to use AI. Oh, me, I don't want to use AI. Without generally realizing that day in, day out, in most things that they're doing, there's one AI usage component in their lives without even knowing. My question is that how should engineering firms Hello? Yes, so how should engineering firms and or engineers generally approach AI adoption strategically rather than reactively? Like, what do you think is the best way for engineers and or firms to approach the adoption of AI by being strategic rather than being reactive?
Okay, thank you. So let me put this simply. So I think that the best way engineering firms could approach this is because of the fear of change. They'd rather not jump onto any AI tool that pops up in the trend. I would advise that engineering firms should rather be mindful of what exactly they feel they would need the AI for. Just like in your presentation, you mentioned that AI is useful for being able to help with administrative tasks that are repetitive, that's, it's in your line of work. So once you identify exactly which workflow you think the AI is useful for, then you look at the tool that is best suited to be able to help you and jump onto it in bits. You don't consume like a big chunk of what you're afraid of, just to be able to help you build some trust and value. That way, we reduce the reactiveness that most firms are having. And at least when trust is built, we can move full scale. So firms could just do this bit by bit. Just to choose clear use cases they feel they could use to test the waters. And then when they are convinced, I think that's there we can build trust and grow.
Hello, but still on that point, do you think there are certain skills and mindsets that engineers would need to have like to actually thrive in this kind of space?
Definitely. I mean, first and foremost, I think that firms should consider in-house training. It's a new technology that sprung up. So you don't expect all of us to be on the same level. And how we assimilate information and build skill is different. So I think one, irrespective of whatever badge you wear, there should be some in-house training to onboard everyone on the basic skills. That usually is the fear of not being able to have a hand on the new tool. That usually brings most of the resistance, because someone feels if we allow this to enter into the system, I'm slow to get in this, so I'll lose my job. But if they know that on its adoption, we are going to be trained on how to use it, they are comfortable knowing that they're okay. That in itself begins to water down the reaction that we get from them. So yes, training is necessary. And hopefully, besides AI onboarding training, basic digital use should also happen. Sometimes we just assume that we all have smartphones, so we are all tech savvy. We are not. Pilots within Microsoft environments. Most of us are using Windows machines. They're not even aware Copilot can be used for even finding their file on their machine. So we need basic IT digital skills training for everybody. And I think from there, we can build on that.
My last question for Manuel, then we can just throw it out to everyone who has a question to also ask the panelists. In recent times, I saw a video of a woman who was actually suggesting to like the government, and I think she used AI to create some sort of like canal with all these like gutters that we have as a means of like, transport system to kind of alternate all the crazy transport traffic and stuff we have here in Accra. But for you, Amano, I just wanted to ask that, is there a more like suitable or sustainable way we can use AI as a tool to actually come up with like, suitable transport systems that are also sustainable in our country?
Yeah, Aaron. Yes, definitely. I would say that the first thing, and I've been mentioning this over and over again, is to get the digitalized data. And once you're able to get information that we need to solve a particular problem digitalized, AI has the capability to help us process this data faster. Now, in terms of safety, so your question is two-pronged, safety and sustainable transport systems. In terms of safety, a few things come to mind. If you're able to collect continuous visual data, AI, for example, can help us predict and even prevent crashes. So it could say, for example, if we had a location where crashes almost happen, where there are near misses, it could recommend interventions before the crashes happen. It could also detect speeding, unsafe driving, and this information can help agencies make do enforcement or produce targeted solutions. And in terms of sustainability, I think that when we start thinking about AI and the shift away from traditional engineering solutions, which, by the way, most of them have been solutions for the Western world, we can start thinking of how we as Ghanaians move, how we move, not just with vehicles, not just with shared taxis or trotros, but that we have people that walk, so if you think about our system holistically, we can come up with solutions that are out of the box. And and those solutions will tend to last more than textbook solutions. Another thing in terms of sustainability is that if we're able to make our traffic move more smoothly, we will reduce fuel consumption, and that always has an effect on carbon emissions. So, yeah, AI is definitely a good tool to contribute to safer and more sustainable systems in Ghana.
Thank you, Emmanuel. Now I'll just open up for everybody. Oh, Presido. Okay. Okay. There are some questions online as well. So, I mean, if that can be shown, we can also read them directly. And then if it's directed to any of us here, we could answer. But in the meantime, I think Presido has a question. So I would.
Thank you. My question is to Amanwa. Yeah. Have you done some research on junction safety and efficiency using AI? What do you call it? Disruptive technology. Yes. So have you done any where you can use your findings to improve junction design, etc.?
Yeah, thanks. I think I missed a little bit of the question. You said, have I done any research on junction design? I think you said something else that I missed, but I'm not sure.
I said AI in improving junction safety and efficiency.
Okay. Yes. I have read a lot of papers and I've seen a lot of demonstrations on how AI can help with junction or intersection design, as you mentioned. And one of the things I mentioned earlier was in terms of safety, AI can analyze intersections where there are near misses. So crashes haven't happened yet, but the way vehicles are moving from data that has been collected from videos over a long period of time, it's able to tell which of the approaches has a higher risk for crashes and whether that should be mitigated. So that's something that I've seen happen out there. In terms of design, it's also linked to safety. Sometimes the videos analysis can show you that maybe the curb design is not adequate, or the lanes are too small or the lanes are too wide. It can bring out different things that it can give you insight so that you can modify the design of an intersection.
Okay, just the last bit. What's your take on, a lot of the vehicles now are AI responsive. The route markings does have an effect on the way you drive. Lane departure, it sends a signal. And as a matter of fact, intersections, and you get to other places, and the car can stop because it just predicted an accident and it just stopped. And what's your advice on our Department of Urban Roads? Because you have these trucks to just drive right in front of your car and the car will just stop. And that can also create an accident scenario. So what do you say about, and the way we mark the quality of paint also affects, because if it's not the right paint, the sensors in the car will not pick up the route markings, and then that also creates a problem. I don't know what your recommendations would be for every Department of Urban Roads.
Yeah, thanks for that question. So this is something that I actually read about. I read a paper about something similar happening in Louisiana. So they were talking about autonomous vehicles reading lanes, and the problem was that the Louisiana Department of Transportation did not have enough maintenance on the road. So some of the lane markings were not wide enough, or they were chipping away, and so the vehicles were not able to recognize the lanes well. And so I think that is definitely an ongoing challenge in many places, including the US. And while AI can analyze things, I think, like Dr. Prince mentioned, it's garbage in, garbage out. And so my suggestion, I think, is two-pronged. AI can analyze things, but if you don't give it enough information or enough solid information, it might not be able to produce what you really need. And so, in my opinion, we'd have to prioritize lane markings, and we have to prioritize maintenance and marking the lanes well so that the AI can do its job. Hopefully with money that has been saved from other tasks that we did with AI. You also mentioned, I think the second part of your question was about urban roads and how sometimes truckers just stop and the whole traffic situation is chaotic. Again, we can take video footage and really see what is contributing to truckers just stopping on the way. Would it be like a demand problem where they see that customers or people that want to board are stopping at particular points, and so that's what makes them stop abruptly? So that's something we could check out. And some of the solutions could be enforcement. Some of the solutions could be a whole redesigning of how the truckers get off the roadway. But I think we'd have to look into the data to see exactly what's happening. And that would be my recommendation.
Thank you. Just for the record, the previous questioner is our past president, engineer. Is it Leslie Aye? But there's Alex, engineer Leslie Alex Aye. Thank you for gracing this occasion with your presence. Thank you. Well, I'm exercising the chairman's privilege now. I want to ask my question. My question goes to Dr. Prince. I'm asking you because you are an educator in the AI space, more or less. I think you even introduced as a mentor or something like that. I want to know what your take is or what your feel is. What do you think the uptake of AI is in this country as far as professional practice is concerned? Not only engineers, but doctors, whoever. If you look at this panel critically, it's a 4-member panel. You are the only person who lives and works in this country full time. All the other 3 are foreigners.
Oh, just
Some
to
live in
interject,
Europe,
I'm
some
not a
live in
foreigner.
America.
I'll be in Ghana by
You see.
January, permanently, just so.
You see, and actually when we were scouting around for the panelists, it really became an issue because we could not very, very obviously identify people who would say are regular users of AI. And we had to reach out to our brethren in the diaspora. So I want to ask you, all these people who pass through the computer science, IT, computer engineering space, do you have a feel that they are, deploying AI as it should be in Ghana?
That's a heavy one, but let me try and digest it this way. So first and foremost, I think that it's an issue of mindset. Many of professionals we find in the country, both those who are just passing through school and those who are out of school for a while and have built businesses, based on the kind of mindset that they run with, affects how they go about consuming and tagging onto technology and trends. I am very much well aware of a few individuals who actually use AI in their practice. They deploy solutions countrywide, and they have intelligence analytics dashboards that are AI heavy, just to be able to help to analyze and give insights into the data that they collect. At least I know 2 of them, and they are working in high-end projects within the country. So yes, and there are those also within the same qualification ranks who also oppose it. Oppose it so much that even if you are not careful and you mention it in technology in a response to anything in any conversation, you become an enemy. So I feel it's more of a mindset and personality issue. We will move away immediately from what we can benefit of this Pandora's box that the world has been given, and rather spend energies fighting against what we don't understand. So are there professionals here who are using the AI? Yes, there are. Most of them are available, yes, but unfortunately, we seem to work in silos. So you don't have a community who are advocating for we taking advantage of this. The reason why I agree with Kwabena when he says it's great to see GHIE, such a great institution, actually putting up a program like that suggests that you're in support of it. That's a great thing because we rarely see that happen. At best, it's within an office in a small unit, or you have boldly come out to say, look, let's not fight it. Let's see what we can use about it and expand the conversation. So yes, there are professionals, but they are hidden. And then there are those who are also against it.
I see some people ask about data security. Will the data you load into your system, such as your reports, etc., be ring-fenced and not accessible on the internet? Yes, I mean, I think data security is a core consideration when it comes to working with anything that has to do with documents and data and all that. And the system has to be designed in that way before it is actually deployed. I think with Boujwek, the concept is that access is controlled through authentication and user level permissions. So you can't just, get access to someone's data because they have uploaded it onto their tool to actually work. There are other organizations that even have stricter requirements, I think. And I think there's also the flexibility to explore like privates or like dedicated like deployments as well. So you can't just have access to someone's document or data just because they have uploaded it into the Bootwork tool to use, because there are authentication ways to actually get it. I mean, while the goal is to ensure that there's efficiency through the use of AI, I think we do not have to compromise on like confidentiality or data integrity in any way. And we have to be professionally responsible as well. So to answer, what's his name? Mr. Kwabna Bempong, I think there's a lot of protection for you if you use the Bootwork tool. Thank you.
So, sorry, but I want to address something on that question. As for Bloomcore, we are quote unquote a European company, so we are by law forced to follow GDPR, which is like the European Union framework for handling data. So every client that we deal with at an institutional level, and even on a personal level, depending on how things would work, there's going to be a data processing agreement that obviously will be signed. That would include all the rights that you have and what we can do with the data. But logically, we always try to reserve the right to train on the data and to be able to use the data to improve the intelligence of the agent. And one way that that could happen, but still protect you, is that others may not be able to access, let's say, sensitive private information that are needed. So there are robust, let's say, data processing agreements that can be used to protect people that put data into our system.
Or someone is asking if it can be used in simulation for water ecosystems.
Not at the moment, but so the way we like to look at Polaris and broadly what our mission is a set of Legos, right? So currently we are building a structural engineering agent. It has tools, context, stuff that are assembled together for it to work well. There's nothing that stops us from leveraging the same concept to, you know, applying geotech or applying, I don't know, what do you say, water resource management, etc. It's just a matter of context, tools, and the way you would orchestrate the agent to work in that particular domain. So when I look at our grand mission, let's say in the next 10 years, Polaris might look vastly different, right? You won't just interact with it just for structural engineering, but for other engineering applications as well.
Okay, I think I have exhausted most of the questions online. If there are any final questions here before we bring the event to an end, I can take them. Or we can ask the audience direct questions as well. Okay, yes.
Okay, so my question has to do with the business aspect of things. I was just wondering, for young construction firms, how would AI help us be more competitive in terms of bidding more contracts and winning bids in general? Like, how do we use AI the right way to be more competitive?
Thank you for the question. I think having a collective space where you have data about, you know, certain cost of projects and how certain projects have been executed actually gives you an informed decision when you go into any like bidding process in the first place. I mean, once you have the analytics of what you can do and your capabilities, you as a young firm wouldn't even want to go into any kind of bidding war with certain companies. If you have an informed decision based on the strengths or like your budgets, what you can allocate, how long you can even stay within a project. In most cases, this space where you actually pre-finance as a firm, basically, I think when you have a lot of information with this, you are able to even like inform yourself as a young businessman to, you know, go into certain like biddings and avoid certain things generally, so you just don't end up being stuck financially. For example, this tool does for you is that based on works that you have done, based on the expenses that you use, based on even your own like financial allocations, it gives you advice on what you can do next, what you can't do, and basically what you can even take up as well. So as a young engineer using this, it can actually help you in so many ways. Obviously, you don't have to also have a bigger team to actually do certain things. It cuts down your costs right at the beginning because there are so many administrative things that you can actually just sit back and actually handle them here to actually save you a lot of money into taking up other projects like going up. So as a young engineer, I would advise that a tool like this is actually very, very good for you. If you are a young firm owner, you can come and see me and we can have a conversation. Thank you.
Maybe let me add to this. So besides that, there are a number of AI tools that you could use to help put your thoughts together and put documents together for bidding. They exist. So maybe we can have the conversation so that it won't look like I'm advocating for a particular tool, but they do exist. I know a few, I've used a few on a few teams. We used to put together documents to bid for calls, grants, and all that. So yes, and they are free. Let me add that, free. So you don't have to subscribe to anything, no payment.
I just want to add quickly to them. I think one way to look at AI for your particular application is that it's a force multiplier, right? So it's actually, when you look at AI, it's pretty good for lean teams. Much more small teams, boutique firms that are really using AI. It's more like you can punch above your weight. So you can, run the numbers, give probably bid on more projects than you could do with, like, let's say, human, let's say, labor, for example. And the quality of the bids you're going to generate are going to be better, and the quantity will be better. So in the end, you would start sort of, let's say, 10x in your output without any increase in headcount. So you can look at it from that point of view where you are leveraging the AI to sort of as a force multiplier for your team. And it's actually quite good for lean teams. If you look at what we've been able to build as like just a team of 3, largely it was just mostly me and my CTO in the trenches, coding and trying to get things done. Like a couple of years ago, we would have needed like a huge team to build what we have. But just a lean team, we're able to pull this off. So it's the same thing what exists in other industries as well.
Yeah, thank you very much. My name is Balonga. I have a question, and then I also have an understanding. So now that you've elaborated a lot about AI in the domain of civil engineering, which is very much understandable, and then a lot of us, including myself, I'm very, very excited to be part of this event. So now my question is that a lot of possibilities when it comes to using AI in construction industry. But what we have jumped, maybe, I don't know, maybe I am the one who did not pay attention, but I didn't see where you've also elaborated the restrictions that we can be very careful when it comes to using all these possibilities like software like Boardwork and the other one, Polaris. So that was the question I have to
your name again?
Balonga.
Okay, Balonga, thank you for asking that question. I think there are 3 sessions to this lecture. And what we try to do in this fund is to talk about some of the tools that we are using. I think the bigger conversation comes up in the subsequent sessions where we talk about the ethical aspects of using this and the professional aspects of using them as well. So this is my special invitation to you that the next topic is on the 7th of May, and we'll be having a conversation about AI use in the civil engineering space, the ethical aspects of it, as well as the professional, restrictions and things that we have as well. So we're just trying to stay in context with the tools that we are using now, But I think the bigger conversation, like you're saying, should be the ethical, like, the boundaries that we have, what we can do, what we can do. And I think a general conversation would be have about that too as well on the 7th of May. So I hope I'll see you here.
Yeah, definitely. I'll come around.
All right,
thank you.
Thank you. Stephen, I wanted to find out what you presented on. Is it available online?
No, it's not. Mine is not online yet.
Well,
I can give you access to it. I can send it to you and you can just play around with it. So I don't have a problem.
Okay. Thank you.
You're welcome. All right, so I think at this point, we'll just take our closing remarks from Chairman. Okay, last words from everybody. I'll start from Doc and then end on Chairman.
Okay, thank you. So I will simply say that AI is a Pandora's box. It's been open and it has no boundaries assistance. Early on before the event, we we're having a conversation about the fact that assistants, the whole world is at par. We are on the same level. Every part of the world is figuring out how to make the most of AI. It's not just Africa or Ghana. So this is the best time for us to come together and figure this out so that for once we'll be at the table with the giants and not be leapfrogging, waiting for them to advance and then we'll be chasing. Because trust me, we've been around a few places separately, and then it's the same feeling around on all the sides of the globe. So I would advise or admonish that we come together and look at how best as an engineering institution or our engineers, we can make the most so that we can build our own agents, automate our own workflows, and start working smarter and intelligent and not just working hard. Thank you.
Amanwa, you can also.
Yeah, I'll build off of what Dr. Prince said. He's absolutely right. We are all at a level playing ground now, or almost at a level playing ground now. What I'd say is that don't be afraid to try this out. This is not just for a few people who are experts. This is for all of us as engineers. The training that we had in school, I think, is more than adequate for us to explore what these AI tools can do and how it can improve Ghana. So don't be shy. Just get on any of the tools that are around and explore it for yourself. Think up an idea, how you can apply civil engineering principles to it, and then get familiar with it so that we can improve the nation as a whole.
Hello. Okay, so my remark will be quite simple. I would say just roll up your sleeves and just build. I think we have this tendency in Ghana, everywhere, where we like to, over-intellectualize things. Just get in the trenches, write your first line of code. Now, code generation is quite easy. Just talk. Hello. So just start building, right? And start using the tools. It might be clumsy at the beginning, but there's no way around it. Don't wait that your colleague goes to learn it and comes to teach you. That period, that era is over. Just sit in your room and start using the tools. And that's how you learn, by building with them. Yeah.
With my closing remarks, I think I'll just take what Kwabena shared with myself and Doc a couple of hours ago about the fact that AI's presence now is literally here to stay. I mean, whilst we are not so far behind as compared to other countries, we are also not really there yet. So, I mean, whilst we keep trying to be innovative, trying to find solutions and all that, we should realize that in other aspects, we are really far behind. It could be in what the structures we have, the systems and other things, we are far behind. When it comes to AI, Ghana can actually compete with other countries because we are really, really not behind, not to even use the word far behind when it comes to this. So we as individuals, engineers, researchers, anybody, we should just try as much as possible to engage in conversations in the use of AI and all that to just make things very efficient, try to be innovative, and to be problem solvers, I mean, for the country or for our organizations or wherever we find ourselves. So thank you very much. I would give Chairman the last word so that we can all leave. So.
Thank you. I was actually going to give a few closing remarks, but my attention has been drawn to the fact that there are some questions online. We're trying to find those questions. If we get them, is there? Well, we can't see the questions here. What? We've already read some questions and dealt with those ones. So, okay, then that's fine. That's fine. Okay. So, like Aaron mentioned, this is supposed to be a three-stage activity. The first one is the tools. The second one, we are hoping to focus on engineering, judgment, and professional practice. That's where some of those issues you mentioned will come. And the third one, finally, will be on ethics, regulation, and the future of AI. So those will be the next two steps. We hope we've engaged you enough and you find it interesting enough to come for the next one and the next one. It is our responsibility as an institution to, as much as possible, prepare our people for the future. And the future is now. So we're doing this so that everybody is adequately prepared and then can survive.